to Lost Creek Nature Retreat. I'm Dr. Holly Dobbins, and I'm here in central New York in a temperate deciduous forest.
A deciduous forest is comprised of a mix of hardwoods that lose their leaves every fall and go dormant through the winter, and some evergreens, but it is dominated by hardwoods.
So we've talked about what deciduous means. Now let's talk about what temperate means.
Located between the tropics and the Arctic or the Antarctic, temperate deciduous forests are exposed to both hot and cold air masses between -20 and 90 degrees Fahrenheit and have 4 seasons.
The second component is precipitation. Temperate deciduous forests typically receive between 30 and 60 inches of snowfall and rainfall a year.
We are located in the Tug Hill region, with Lake Ontario 30 miles to the west, the Adirondack Mountains 30 miles to the east, and Oneida Lake 2 miles to the south. This creates a corridor, causing a unique climate condition, where the moisture-laden air of Lake Ontario is carried by the prevailing winds and trapped against the Adirondack Mountains. This is the same orographic effect that occurs in the Pacific Northwest, resulting in an unusually high amount of precipitation. We have about 45 inches of rain per year and about another 113 inches of snow. Our closest city, Syracuse, is ranked number 1 in snowfall and is the 4th rainiest city in the United States. Geologically, our region was shaped by glaciers that left drumlin hills and carved cove forests, causing a variety of elevations. That, in combination with the abundance of water and the history of responsible land management, has allowed the emergence of over 10 distinct microecosystems, all occurring within the 150 acres here at Lost Creek.
Temperate deciduous forests have tremendous biodiversity because of the wide range of habitats and food sources. Out of all of the major biomes, only tropical rainforests have a greater number of species. Because of the unique conditions here at Lost Creek, we have 5 distinct ecosystems. Our Northern Hardwood Forest, coniferous forests, meadows, a chaparral, and wetlands. And the wetlands can be further broken down into 5 distinct microecosystems, but I will talk about those later. Let's go explore a temperate deciduous forest. Our largest ecosystem here at Lost Creek is the Northern Hardwood Forest, which is specific to southeastern Canada and northeastern United States. It's often considered a transitional forest because it contains species that are common to both deciduous forests of the south and boreal forests of the north.
Our hardwood forest contains a mix of common species: beech, maple, oak, black cherry, tupelo, birch, poplar, basswood, as well as some of the rarer species: American chestnut, black walnut, hickory, ash, and pawpaw. This area is dominated by beech trees, and one of my favorite characteristics of beech trees is the wonderful smooth bark. As you can see, there are not a lot of large trees in the area. That's because over a century ago it was clear-cut for farmland, lumber, and firewood. This stone wall was created by farmers when they removed the stones from the clear-cut fields after plowing. So in terms of succession, this forest is younger but in transition to a mature forest as the understory bushes, herbs, and mosses grow and develop. But not all the giants were cut down. There are a few pockets of old growth and hard to reach places such as
this impressive beech growth. Beech trees can live up to 400 years and generally grow to about 80 feet tall. These are over 150 years old, but they're in trouble due to an invasive species called beech scale. This tiny insect bores into the bark and once infested leaves it vulnerable to infection. Two fungi then enter and form these cankers. Sadly, from the state of the bark on these trees, these old timers are not likely to survive.
Beech trees are prolific nut producers. The protein-packed beech nuts are a critical food source for many forest dwellers such as deer, turkey, grouse, and squirrels. However, they only produce nuts every 3 to 5 years, based on a strategy called masting. Trees will have no nuts for several years, and then produce a bonanza of nuts during a mast year. This strategy has evolved for 3 major reasons. First, it takes a great deal of energy to produce nuts, and when they do, it stunts their growth. Therefore, it's not something they can afford to do every year. Second, the overabundance of nuts during mast years overwhelms the consumers, ensuring that some will survive to take root. Thirdly, during off years, the short food supply results in a decrease in the numbers of consumers, which also adds to the seed survival rate when a mast year finally does occur. Not only do individual beech trees produce this surplus of nuts during mast years, but beech trees will synchronize their production. This is known as the Moran effect, when populations of species respond to environmental cues and act together. Warm, wet winters and dry springs, along with specific temperatures occurring during flowering, result in beech trees in the same area, all producing copious amounts of nuts at the same time. This relationship between a varying food supply and a consumer population is called a boom and bust cycle. Not only does it occur between nut trees and squirrels, but it reverberates up the food web to the predators of squirrels. More squirrels results in more squirrel-eating predators, such as birds of prey, foxes, and coyotes. An increase in squirrel population results in an increased predator population, the boom. More predators will eventually use up the prey population, followed by a sharp drop in predators, the bust. Boom and bust cycles playing out over time is nature's way of maintaining the overall balance of an ecosystem. Squirrels are not only one of the primary consumers of beech nuts, but they also aid the trees with their propagation. During mast years, after the squirrels have eaten their fill, they will carry the nuts off and bury them for future use. They are remarkably skilled in finding the nuts at a later date, but are never able to find them all. The missed nuts will then germinate, allowing the beech tree to spread to new locations. This relationship makes squirrels what we call a keystone species in a forest. A keystone species is any organism that has a significant impact on an ecosystem compared to other species. They are called keystone because, much like the center stone in a stone arch, without it, it would collapse. If these species disappear, the ecosystems they inhabit would be radically different or could collapse altogether. The mighty oak. Renowned for its majestic beauty, a symbol of strength and durability in many cultures throughout the ages. With a lifespan sometimes over 400 years, its massive trunk and exceptionally wide root system enables the oak to tower above the canopy and still withstand the great storms and adverse conditions without blowing over. Their roots can sometimes reach out 3 times the width of the crown. Oak's extensive root systems help to stabilize the forest as a whole. Just as the 14th century English proverb teaches, mighty oaks from little acorns grow, reminding us that sometimes the greatest things have the smallest beginnings. Oaks are another keystone species in eastern deciduous forests, providing both habitat and food. The acorns they produce are eaten by over 100 different vertebrate species. Similar to the beech, oaks also use a masting strategy, but in a different way. White oaks, for example, actually produce acorns annually. When conditions are right, a mast year occurs, where they produce an overabundance of them. Just as with the beech tree, this overwhelms the consumers. The squirrel, along with many other species, can eat their fill while leaving enough left over for germination. The other species of oak here at Lost Creek, the red oak, is the fastest growing and largest of all oaks native to New York State and can grow in the coolest regions. This allows the red oak to grow to heights that are at or above the dense canopy in a mature forest. Red oaks also utilize a masting strategy. However, because they take 2 years for their acorns to mature, remaining on the tree over winter, they only produce acorns every 2 to 5 years. Acorns are one of the richest sources of proteins, fats, and carbs in the forest, and are a critical food source, highly sought after by the white-tailed deer. In the fall, does need to replenish their depleted bodies after having given birth and nursed their fawns throughout the spring and summer. Fawns need to finish their growth cycle. All deer need the extra energy to grow their winter coats, and bucks need the extra calories and protein as they grow new antlers and develop muscle for the upcoming rut. Acorns pack 13,000 calories per pound. Deer gorge themselves non-stop, day and night, for several weeks in an effort to put on fat to prepare for the lean winter months ahead. And even with the great bounty of acorns available, competition is tough and squabbles still arise. But it's not a one-way street for the oak tree. In return for receiving this nutritious feast, the deer provide something essential back to the tree. Fertilizer. As the deer search for acorns near the base of the tree, they leave behind their droppings. In this way, deer play an important role in the nutrient cycle distribution in a forest ecosystem. Deer are browsers, and browsers perform a vital role in shaping the forest. As they move through the forest understory, selectively nibbling and chewing their way, they limit the growth of shrubs, bushes, and tree saplings. Without this browsing, many areas of a forest would be virtually impassable for larger mammals, including humans. But browsing does not just open up the forest. Many species of shrub, particularly berries, require new growth to produce fruit. So in essence, deer are the forest's pruning crew. By opening up the understory and promoting new growth, deer browsing results in a greater diversity of species, and is the primary reason deer are also considered a keystone species. However, as with all good things, there needs to be balance. When deer populations are too high, they can overbrowse, hindering the growth of tree saplings, shrubs, and other understory plants that provide essential habitat and food sources for various smaller animal species. Deer also prefer eating native species. This selection can allow invasive species to take over. Maintaining a healthy balance of species in an ecosystem requires predators. Introducing Lost Creek's apex predator, the Coywolf, also known as the eastern coyote, a hybrid between the western coyote that migrated east in the 1950s and the few remaining native gray wolf populations that had been decimated due to overhunting. The Coywolf has the advantage of having desirable characteristics of both species. It has the adaptability of the coyote, enabling it to live in closer proximity to humans, along with the larger size and jaw strength of the wolf, giving it access to larger prey. Contrary to popular belief, coy wolves and coyotes are not a threat to deer populations. Because of this misconception, many hunters will tragically shoot any coyote they see. The truth is that they are a keystone species and play a vital role in maintaining healthy deer populations. With the near elimination of native apex predators, such as bears, mountain lions, and wolves in the 19th century, deer populations exploded, requiring human intervention. This was accomplished through hunting, and while hunting has done a fairly decent job of limiting the deer population through the last century, there are drawbacks. Hunters tend to shoot the biggest, strongest animals, often looking for trophies. This practice can interfere with the process of natural selection, whereas coy wolves will rarely take down a healthy full-grown deer, save on rare occasions when they are stuck in deep snow or in a muddy bog. They are, however, the number one cause of fawn predation, which is a very effective way to limit the population. More importantly, coy wolves cull the herd by taking the sick and the weak, which stops the spread of diseases such as mange and other diseases caused by close contact due to overpopulation. Additionally, the number of human hunters is decreasing. There are several reasons for this: urban expansion, the lack of access to hunting areas, and the lack of free time as more people have to work longer hours to get by. Therefore, we increasingly rely upon our apex predators to maintain our healthy deer populations. Not only are coy wolves essential in managing deer populations, but they also control rodents and other small mammals such as raccoons. With any species, overpopulation can exceed the carrying capacity of an ecosystem. This results in the spreading of disease, destruction of habitat, and even mass starvation. This is another example of the boom and bust cycle. Another nut-producing tree we have here at Lost Creek is the American chestnut. They are in the same family as oaks and beeches, the Fagaceae family. American chestnuts once dominated eastern deciduous forests of the United States. The trunks often exceeded 6 feet in diameter and reached heights of 100 feet, making it one of the most massive trees in the deciduous forest, second only to the sycamore. Unfortunately, American chestnuts have now become very rare because of a fungal infection called chestnut blight that was introduced to the United States in the late 1800s due to importing chestnut trees from Asia for commercial breeding. This is an extremely rare example of a mature American chestnut tree. Once a significant food source for both wildlife, humans, and livestock, chestnuts are even more calorie-packed and nutritious than acorns. Prior to the blight, they were an important keystone species. American chestnuts are distinctive and easily recognizable because of their spiny outer casing. Mature individual trees either produce male or female flowers. Therefore, they require cross-pollination in order to reproduce. They are pollinated either from the wind or insects. Even though this one is producing nuts, sadly, the nuts are not viable. Because there are no other mature trees close enough to cross-pollinate, these seeds will not be capable of germination. If the seeds were viable, when they fall to the ground, the spiny outer casing opens, depositing the seeds into the ground. At the same time, the case acts as a protective covering that prevents them from being easily eaten by consumers. We are lucky enough to have dozens of healthy young American chestnut trees here at Lost Creek, which indicates that we have had mature trees with viable seeds that propagated within the last 5 to 10 years. We are hoping that these have some blight resistance and may make it to maturity. Unfortunately, it is more often the case that when young American chestnut trees almost reach maturity, they are attacked by the blight and die within a couple of years. Yet American chestnut trees are very resilient, and even after dying off above ground, the stumps can live on for decades by producing sprouts that repeatedly grow and die off, forming a shrub. Within 50 years of the blight's arrival in the United States, the American chestnut tree has been reduced to a shrub species, rarely reaching 30 feet in height. However, there is some good news with regard to the American chestnut. Some few mature trees have been discovered to be resistant to the blight and are being propagated. Efforts are being made across the country to bring back trees that can reach full maturity. We at Lost Creek are part of that effort by introducing known blight-resistant trees into our population. While we will likely never restore the American chestnut to the dominance it once had in our lifetime, we do hope to bring it back to a sustainable level. This is one of 2 active warrens here at Lost Creek. A warren is a system of holes or burrows dug in the ground with interconnecting tunnels, often located high on a bank or hill above the danger of flooding. Warrens can be dug by a variety of forest creatures and are used as dens for raising offspring, providing shelter from the elements, and protection from predators. It is not uncommon for them to be used by several different species, often at the same time, and they can be expanded over the years as each new resident makes improvements. Warrens tend to be a magnet for wildlife, not just for the hole dwellers, but also for many other forest creatures. There's a reason for this, but it would not be obvious to a human passerby. That's because forest creatures have a superior sense of smell that opens up a world of odors that we are incapable of sensing. That world of odors is what attracts so many creatures to a warren. Some animals that pass through or explore the burrows unintentionally lay down a scent trail. Others deliberately leave their scent to mark their territory or attract a mate, which we can see here as this porcupine rubs its scent glands on a branch stub protruding from this fallen log. Think of it as nature's version of a social media message board. This abundance of scents and odors attracts even more attention. Predators. As fall approaches, the days get shorter and the temperatures begin to drop. This triggers a spectacular transformation in a northern hardwood forest. Deciduous trees begin a process that prepares them for the harsh winter months ahead. They must enter a state of hibernation that will allow them to conserve energy and provide protection from heavy snow loading and extreme cold. The first thing they do is shut down the process of photosynthesis that normally occurs in their leaves during spring and summer, as they convert sunlight energy into sugars that fuel the tree. With less sunlight, producing the green chlorophyll required for photosynthesis would require more energy than the chlorophyll can produce, so it's more efficient to shut down the process and shed the leaves. Without the green chlorophyll, the true pigments in the leaves show through, revealing a colorful array of red, yellow, and orange. Each species of tree will have its own color, with the most famous being the red maple. Some of the most breathtaking vistas in nature can be seen in a northern hardwood forest in the fall. Another reason trees shed their leaves is to prevent snow damage. Less surface area for snow to build up on reduces the weight on limbs and branches, minimizing the risk of breakage during heavy snowfall. But not all deciduous trees follow the rules. Beech trees have adapted the peculiar behavior of holding on to their dead leaves throughout the winter. They are easy to identify in the winter landscapes for this very reason. There are two hypotheses for why they do this. The first one suggests that the old dead leaves act as mini solar panels that heat the new buds forming nearby. In the spring, that heating accelerates bud growth to produce new green leaves ahead of the other trees. This is particularly advantageous to young small trees growing in the understory, giving them a head start before the canopy closes in above them. This is one of the reasons the beech is a relatively shade-tolerant tree. The second hypothesis suggests that the dead leaves hide the new buds from browsers. Again, this is especially helpful for the young trees, growing close to the ground within reach of the browsers. Interestingly, all three species of nut producers in the Fugaceae family, the beech, the American chestnut, and the oak, all exhibit this same adaptation. Fallen leaves play a critical role in the forest ecosystem. They contribute to a layer of organic matter on the forest floor known as duff. As it decomposes, vital nutrients are returned back to the soil for reuse by plants and trees. It helps maintain a loose aerated soil that aids in seed germination and promotes root growth. It also helps prevent erosion and regulates forest moisture levels by absorbing heavy rainfall and storing it for release later during dry conditions. Duff is the foundation for the bottom rung of the forest food web, providing habitat for a host of insects, invertebrates, and microorganisms. These then provide a food source for an assortment of birds, amphibians, and reptiles. As the trees prepare for winter, many forest birds take advantage of their ability to fly and begin their migration to warmer climates. Starlings, robins, hummingbirds, goldfinches, scarlet tanagers, bluebirds, and orioles are some of the birds that relocate, as well as most waterfowl when the freezing of waterways eliminates their food sources. Some of the birds that are able to find enough food during the winter and elect to rough it out are blue jays, cardinals, ravens, ruffed grouse, and wild turkeys. Some raptors also remain, like the red-shouldered hawk, barred owl, and turkey vulture, that will prey on birds and small mammals that are active throughout the winter. They will also scavenge on the carrion of animals that have succumbed to the harsh conditions of winter. The forest creatures that don't leave for warmer climates are busy preparing for the upcoming winter in several ways. Larger mammals enter a period of insatiable hunger, no matter how much they eat, called hyperphagia. This is necessary to build up fat reserves that they can live on when their normal food sources are no longer available. Smaller mammals are busy storing nuts and seeds in accessible locations that they can return to throughout the winter. Reptiles, amphibians, and invertebrates go underground to escape the freezing temperatures. This crawfish is doing its own mini-migration as it travels upstream, looking for a large pool or pond so that it can bury itself in the mud. As the cold grip of winter closes on Lost Creek, a snowy silence covers the land. A new season has arrived, continuing the cycle that has played out again and again over the millennia. Winter means hard times for the forest animals, predators and prey alike. While the trees slumber in their hibernation, the animals seek protection from the harsh conditions. Some seek shelter underground in the burrows of the warrens, and in the case of the groundhog, enter a state of true hibernation where their metabolism slows and they rely on their fat reserves to get them through winter. Others take refuge in hollow trees or fallen logs. Prime real estate is high in demand, and squabbles can occur for owners' rights. Most of the animals do not fully hibernate. Some go into a semi-hibernative state called torpor, where during warm spells they will leave the protection of their dens to stretch their legs, get some fresh air, and search for any food that might be available. Even though raccoons are normally solitary animals, It is not uncommon for young ones, or even adults that are potential mates, to den together to share body heat. This couple is getting in some well-needed grooming. The top predators are active all winter long and must constantly search for food. Even though they are nocturnal and prefer to hunt at night, scarcity of food in the winter can force them out into the daylight. This is a very rare daylight sighting of a magnificent gray fox sporting its luxurious multicolored fur coat. Smaller predators must eat every day or two to maintain their body heat. The high energy of the fisher comes with an equally high metabolism that during the winter pretty much requires it to hunt any time it's not asleep. Larger predators can go a few days without eating, but no longer than a week if they are to maintain a healthy condition. This can be a real challenge with the majority of their prey safely tucked away in their cozy dens. While most of the forest creatures are able to take refuge somewhere during the winter, there is one animal that does not have that luxury. Deer cannot hide in a tree, nor can they hide in a hole, nor even under a brush pile. They are exposed to the elements day and night, snow or sunshine. Fortunately for them, they are perfectly adapted to handle these conditions. Their thick winter coats have hollow hairs that trap air and are so efficient at holding in body heat that snow falling on their backs does not melt. They are so well insulated that when they need to sleep, they simply find a protected spot, maybe with some warm morning sun, lie down, and curl up into a ball with their heads tucked into their tummies. These oval-shaped circles melted in the snow are a sure sign that deer slept here. Deer must also eat non-stop during winter months due to the low nutritional value of the browse they must eat. When the snow is not too deep, they can still dig down to find some grasses, nuts, and mosses. But when the snow deepens, they must shift their diet to less desirable browse they would not normally eat, such as twigs, branches, and even evergreens. When food is scarce, they will even resort to stripping the lichen off trunks of trees that is still reachable above the snow line. Another adaptation that allows the white-tailed deer to survive hard winters is their extraordinarily strong digestion system. They can even tolerate small amounts of highly toxic plants such as milkweed, poison ivy, and this rhododendron. The one thing that deer are not well adapted to and can cause serious trouble is extremely deep snow. Those long legs and sharp pointy hooves make them lightning fast on solid ground. But they become a real handicap in the deep snow, especially deep snow that has gone through some thaw and freeze cycles and has an icy crust on top. It is at this time that they are the most vulnerable to attack from the coy wolf. Searching for browse in the deep snow expends a great deal of energy, possibly using more energy than the low-calorie browse actually provides the deer. In an effort to conserve energy, they place their rear hooves in the same holes as the front hooves as they move along. And will reuse the hoof holes from the deer in front of them. This is a critical time for the deer, requiring them to live off their fat reserves. If the deep snow persists too long, and they were not able to put on enough fat in the fall, they could perish. But nothing goes to waste. If a deer does perish or is taken down by a coy wolf in the deep snow, a deer carcass can be a huge windfall for many of the forest animals. Crows harass from the treetops, and this cheeky raven waits its turn as a red-shouldered hawk becomes a scavenger in a time of need. All the top-line predators are also scavengers, especially in winter. A single deer carcass can last all winter. And could mean the difference between life and death when no other food source is available. Deer are not the only ones that have trouble with deep snow. A group of wild turkeys trudges along searching for food. As with the deer, being bogged down in deep snow puts them at increased risk of becoming a meal themselves. They are hoping to find berries and seeds still available above the snow line. Red chokeberry, mountain holly, and serviceberry are some of the shrubs present in the forest understory that hold on to their berries throughout the winter. The berries provide a vital food source for turkeys, ruffed grouse, and both resident songbirds and ones returning from migration in the spring. Ironically, the same deep snow that creates such hardships for deer can also create a life-saving source of food for them when they need it most. The trees shed their leaves to prevent snow damage, but it is not always successful. If too much snow falls too fast, even the strongest limbs can fail. When the bough breaks, the tree branch will fall, bringing down leaf buds for consumption by all. A fallen tree limb brings new twigs and leaf buds that were previously out of reach above the browse line. Deer eagerly seek out fallen limbs and will return to them each day until all of the edible bits are gone. A hardwood forest can be a magical place in the winter. The snow absorbs all sound, and on a calm day, the peaceful silence is broken only by your footsteps. Mother Nature shows off her artistry using a palette of snow and ice. With the sun traveling low across the horizon, the dappled sunlight glistens off the snow and casts interesting shadows across the forest floor. As spring draws near, longer days warm the land. Songbirds sing as winter releases its grip. Trees awake from their slumber with fresh new buds ready to burst. Warm days melt the snowpack, filling the brooks with water as it begins its long journey down the watershed. Brooks fill creeks that swell with the water of life as it courses through the land. The melting snow also floods the forest floor, filling shallow depressions, temporarily forming what are known as vernal pools. Not only do these pools provide a vital habitat for a number of amphibious creatures, but they also replenish surface water when it is needed most. An abundance of water is just what the forest needs as its flora undergoes the most rapid growth period of the year. One of the first amphibians on the scene, even before the snows have melted, is the noisy wood frog. Sounding more like a flock of birds than an army of frogs, they have gathered together in the vernal pools to mate and lay their eggs. They use the pools because they are free from fish and other predators that are present in year-round bodies of water. The idea is to start early, so their eggs can hatch before the pools dry up. Our bachelor group of young male or Jake turkeys made it through the winter. We can tell they are males because of the clump of specialized feathers hanging from their breast, known as a beard. And we can tell they are young because they have not yet developed the classic red wattle and snood that the mature toms sport. Females have no beards and are smaller and less colorful. Hens also travel in groups separate from the males during the winter. Springtime brings romance as the males and females join up. The mature toms fluff and fan their feathers and strut around as they compete for the hen's attention. Their bright blue heads and colorful wattles are all part of the show. The skies fill with the familiar chorus of Canada geese as they honk their way back from their wintering grounds. Canada geese mate for life, and mated pairs will often return to the same nest site year after year. They arrive early, often before the ice has cleared, in an effort to stake claim to their favorite nest site. Both parents will share in the raising of the offspring. A mallard's duck is also searching for a nest site. The more colorful male follows closely. His job is to mate with her daily until all of her eggs have been laid. Once she begins to brood or clutch, she will be on her own. Warming temperatures wake hungry groundhogs from their long hibernation. They waste no time munching down on the newly exposed grasses. Robin redbreast is one of the first songbirds to return in the spring. A male defends his territory while his mate selects a nest site. While the female builds the nest, the male also stays close and mates daily to fertilize the eggs. However, after the eggs hatch, both parents will work together to raise the hatchlings. By April, mated pairs of Canada geese have selected their nest sites and are sitting on a clutch of eggs. Driven by instinct, with new females having never even seen the nesting process before, they select a site, form a bowl with grasses, and line it with down pulled from their breast. The male's job is to keep a low profile while remaining nearby. His job for the next 30 days is to protect his mate and the nest from predators. If a threat is perceived, the couple's first defense is to hunker down and hide. The idea is to look more like a rock or a log than a goose. The red maple is one of the first trees to flower in the spring, even before its leaf buds open. Its brilliant red flower buds give the tree its name, along with its red fall foliage. The bright red flowers attract hummingbirds returning from their winter migration, providing a vital food supply when other sources are scarce. Another early bloomer is the serviceberry tree, so named because its blossoms coincide with the spring thaw that would allow graves to be dug for those that had died during the winter. It is also known as shadbush because it flowers around the same time that shadfish migrate up rivers and streams to spawn. The blossoms provide an early food source for pollinators such as bees and butterflies. April showers bring May flowers. Understory plants spring to life, racing to capture as much sunlight as they can before the taller trees unfurl their new leaves above. Native plants must sprout and produce their flowers quickly before the canopy closes and shuts off their energy supply. There is one understory shrub that uses a different strategy. The rhododendron is one of the few broadleaf shrubs that is an evergreen, keeping its leaves year-round. This enables it to continue photosynthesis throughout the winter, allowing it to survive in relatively shaded areas during the summer. In extreme conditions, it curls up its leaves to prevent freeze damage from the cold, and droops its leaves to avoid damage from snow loading. Chickadees are one of the songbirds that do not migrate. This couple has cleverly hidden their nest in a cavity inside this rotted tree stump. Mated pairs stay together through several breeding seasons and sometimes even for life. Mating for life and staying through winter allows them to get an early start. We know that the eggs have already hatched because we can see each parent taking turns entering the nest to deliver an endless supply of insects. A newly arrived hermit thrush broods her clutch of eggs, relying on her perfect camouflage to avoid being detected. Only 30% of hermit thrush nests will survive until fledging. Young beech trees have finally dropped their dead leaves and are the first trees to have a full complement of new leaves, substantiating at least one of the hypotheses. Springtime brings an explosion of new life to the forest. A hermit thrush chick is the first of the clutch to emerge from its shell. White-tailed deer give birth to the next generation. A 7-month gestation period coincides with the abundance of new browse the mothers will need to produce the milk to nurse their fawns. Mr. and Mrs. Robin have also successfully hatched their eggs and will spend the next 2 weeks non-stop catching and serving up insects for their ravenous brood. Hermit thrush chicks grow fast and also take about 2 weeks to fledge. As with most songbirds, both hermit thrush parents help with the raising of their young. One can only imagine how many insects are consumed by the songbirds in a forest. Not only do they control insect populations, but they also help spread seeds and are an important food source for many predators. While most songbirds are not considered a keystone species, they are, however, an important indicator of the overall health of an ecosystem. One family of birds that is considered a keystone species are the woodpeckers. Especially the largest of all North American woodpeckers, the spectacular pileated woodpecker. As large as a crow and equipped with exceptional hearing, it listens for insects under the bark or deep inside the tree. Once detected, it uses its powerful beak to probe the bark for the insects hiding underneath. It is hoping to hear its favorite prey of all, carpenter ants. Colonies of protein-packed ants, along with their fat, juicy eggs, can often be found inside the heartwood of forest trees. And the pileated woodpecker will spare no effort while chiseling its way deep into a tree to reach them. The excavated cavities are then used as nests by small animals and other forest birds. In some cases, an ant colony can be completely wiped out, which allows the holes to heal and fill back in. So, in some respects, the pileated woodpecker can act as a tree surgeon, curing the tree of its infestation. In addition to creating vital nest cavities and controlling insect populations, woodpeckers also play another important role. They are the forest demolition crew. By breaking down rotted logs, they accelerate the decomposition process that returns essential nutrients back to the soil. It is for these reasons that woodpeckers are considered a keystone species in our forests. One of the more interesting families of trees here at Lost Creek is the Betulaceae, or birch family. Birch trees can be easily identified by their distinctive peeling bark and horizontal striations. Those features, along with the delicate branching moss overlay seen here, can create some of the most artistic tree bark patterns in the forest. But those horizontal striations are not just for looks. They are actually thin openings, or pores, in the bark, called lenticels, and they have a specific function. They allow the exchange of the gases oxygen and carbon dioxide between the inside of the bark and the outside air. Basically, they allow the tree to breathe. Birch trees need to breathe through their bark because they are one of the few trees that are capable of bark photosynthesis. Thin bark allows sunlight to penetrate and reach a layer of green chlorophyll just underneath, where photosynthesis can occur, providing the tree with some energy during winter months when it has no leaves. But that's not the only trick birch trees have up their bark. That same layer that stays green all winter produces a volatile organic compound called methacrylate. The common name is wintergreen, and it is the same compound used in toothpaste, chewing gum, and mouthwashes that gives them their minty flavor. But it does not stop there. Wintergreen also has analgesic properties and is used in deep heating muscle rub creams. One might ask, why do birch trees produce such a compound? One reason is to repel herbivores such as deer that do not like the taste of mint. Another reason is to defend against insect attack. Due to its volatility, it evaporates into the air and can repel certain insects such as aphids, while at the same time attract other insects such as ladybugs that prey on aphids. So in a sense, it gives birch trees the ability to communicate with the forest. If a tree comes under attack, it increases its production of methacrylate to ward off the attack, which is then sensed by nearby trees, triggering them to ramp up their own production in preparation for the oncoming attack. Because methacrylate is an analgesic, or pain reliever, when breathed in by humans, it has a calming effect on the central nervous system. Other volatile organic compounds given off by forest trees, such as terpenes from conifers, can also have anti-inflammatory and immune-boosting properties, which gives rise to a relatively new therapeutic activity called forest bathing. Popular in Japanese culture and known as Shinrin-yoku, it involves immersing oneself in nature and reconnecting with your senses as you take in the sights, smells, sounds, and textures around you. Listening to the sounds of birdsong, flowing water, and gentle breezes, breathing in the forest air that is rich in oxygen from photosynthesis and those volatile compounds, feeling the textures of the trees and mosses, and seeing nature play out before you can all help to reduce stress levels, depression, and anxiety, and improve mood and overall well-being. Another fascinating aspect of birch trees is their tendency to form exotic elevated root systems in a process called stilting. We call this one the elephant leg birch. Other tree species can also exhibit this process, but it is mostly observed in birches for a very specific reason. Birch trees do not produce nuts. They produce cone-like pods called catkins, containing hundreds of very tiny seeds. In the fall, the tiny seeds are scattered by the wind, but most get trapped in the loose duff layer, and while they provide a valuable food source for many forest birds, they will be unable to germinate. A forest disturbance, such as this blowdown, exposes a root ball of the mineral soil they need to germinate. The formation of a moisture-holding mossy cover on top of the mineral soil makes the conditions even more favorable for the seeds to take hold. The seeds lucky enough to fall here have formed saplings that can also take advantage of the abundant sunlight being let in through the new opening in the canopy created by the blowdown. As the tree grows on the root ball, its own roots reach for the ground and take hold while the root ball gradually decomposes. Eventually, the root ball disappears completely, and the tree is left perched on its stilted roots. These root systems also make great hideouts for the local gnomes. Occasionally, the stilted roots cannot support the weight of the tree, and it falls over. Trees are resourceful, though, and after sensing the loss of its apex growth stem, it triggers the growth of buds laying dormant just under the bark called epicormic buds. These buds produce sprouts, of which one will eventually become the new apex stem. When a tree falls in the forest, it's not just the root ball that promotes the growth of new saplings. Over time, the trunk and branches decompose, providing a surface for mosses to grow on and become what is known as a nurse log. The lush moss acts like a giant sponge, absorbing water during wet periods and storing it during dry periods, providing an oasis for germinating seeds and developing young saplings in a forest ecosystem. This nurse log, born from a large black cherry, could take up to 100 years to fully decompose. We can estimate when it blew over by the size of the hemlock that sprouted on and is growing out of the fallen trunk. At 10 inches in diameter, its age should fall between 40 and 60 years old. Add another 5 years for the moss to develop on the trunk that allowed the seed to germinate, and you know how many years ago the cherry tree blew over. Mosses also provide moist habitat for a variety of amphibians, insects, and other invertebrates that make up an integral part of the forest food web and nutrient cycle, allowing for a greater diversity of species in the deciduous forest. When a tree dies from old age or disease and remains standing, it's called a snag. Snags are a vital part of a forest ecosystem because even though the tree itself is dead, it can live on for decades through the many plants, animals, and fungi that will inhabit it. Their hollow cavities provide nest sites and dens for countless birds and small mammals. They provide food and habitat for insects and their larvae, which in turn are food for birds and mammals further up the food web. And they provide nutrients for fungi and their mushrooms, which are then eaten by mammals, insects, and invertebrates. Summer is a time of plenty in the forest. Animals take advantage of the abundance as they raise their young. Red maples are one of the most common species of hardwood trees in the forests here at Lost Creek. They are also some of our largest and oldest, with some reaching heights of 100 feet and ages of 150 years. This majestic example towers above the other trees in the canopy. But not all big trees are old, and not all old trees are big. A better way to judge their age is by their bark. Very much like people's skin, tree bark changes with age too, and has 3 basic stages: youth, mature, and old age. This young red maple has relatively smooth gray bark. As red maples reach maturity, their bark develops vertical, shaggy plates. And if they are lucky enough to reach the ripe old age of over 150 years, they shed their shaggy outer bark, leaving only a red inner smooth bark. It is at this point that they are barely recognizable as maple anymore. When we first discovered this ancient tree during the winter, we mistook it for a red oak. It was not until the following summer, when we were able to see the leaves, that we realized it was a maple. Young black birch trees start out with smooth gray bark with clearly visible lenticels. During middle age, their bark starts to exhibit the classic peeling, papery texture, with the lenticels becoming less obvious. At around the 150-year point, the outer bark starts to peel off in plates, exposing a gnarled, craggy underbark that no longer resembles a birch tree. Young black cherry trees have an olive-green bark with lenticels. However, the lenticels are only for normal respiration. Black cherry trees do not perform bark photosynthesis like birch trees. Middle-aged cherry bark darkens and develops loose, flaky scales. And again, when the tree reaches a very old age, the outer bark begins to shed, exposing a smooth red inner bark. Due to the high value of black cherry lumber and extensive logging, a black cherry tree of this age is extremely rare. This is the only one we have here at Lost Creek.
So we've talked a lot about fauna, which is the animal kingdom. And we've talked a lot about flora, which is the plant kingdom. But there's a third kingdom that so far we've not really touched much upon. It also begins with F, fungi. Of these 3 kingdoms, fungi might be the most important, yet least understood. Without fungi, the temperate deciduous forest would be radically different, if it could even exist at all. Fungi were reclassified into their own kingdom in 1969.
And for the last 40 years or so, mycologists in the scientific community have made great progress in understanding how fungi interact with the plants and animals in the other two kingdoms. Let's dive further into the world of fungi and find out how they play such a vital role in our forest ecosystems.
Scientists have identified hundreds of thousands of species of fungi in the world, and it is estimated that there are millions more that have not yet been discovered. Of them, there are tens of thousands of species that produce the fruiting bodies we all know as mushrooms, and those are the ones we will be focusing on here. As I mentioned, mushrooms are only the fruiting body of a much larger hidden organism that exists in the soil or wood. This organism is called mycelium and is made of thousands of very fine white filaments called hyphae. When the ambient conditions are at the right temperature and humidity for a particular species, the mycelium will produce a mushroom that contains microscopic spores for reproduction. And it is this mushroom that is the part that you typically see. The word spore originates from the Greek word for seed. Mushrooms come in an endless variety of amazing colors and fascinating shapes. So far, we've identified over 100 different species here at Lost Creek, and we continue to discover more each year. They employ many clever methods of spore dispersal. Some use gill-like structures under their caps to release their spores into the wind where they travel to new locations. Some release them through microscopic pores. Others use tooth-like structures. Some use comb-shaped spines. And there's even one with a hollow sac full of spores that requires an external mechanical force to eject them. The spores then grow and develop into new mycelium colonies. Here we can see new hyphae spreading out from the remains of a decomposed mushroom. Mushroom-producing fungus can be categorized into three basic groups: mycorrhizal, saprotrophic, and parasitic. Let's start with mycorrhizal. Mycor is derived from the Greek word for fungus, and rhiza is the Greek word for root. So mycorrhiza literally means fungus root. It's aptly named since a mycorrhizal fungus is one that has a direct association with the roots of plants. The hyphae in the mycelium connect with the roots of plants and transfer water and nutrients from the soil to the roots for use by the plant. In return, the plant provides energy to the mycelium in the form of sugars that are produced in the plant during photosynthesis. Since both the fungus and the plant benefit from each other, we call this a mutual symbiotic relationship. Forest trees depend on this relationship because their limited root systems cannot possibly reach far enough to gather enough water and nutrients to survive, especially during drought conditions. They need far-reaching mycelium to gather and transport those essential elements to them. Mycelium colonies can cover vast areas. A single colony discovered in Oregon, nicknamed the humongous fungus, is estimated to be thousands of years old and covers over 2,000 acres, making it the world's largest living organism based on area. So, one can see just how vital these underground colonies are for tree growth, but it doesn't stop there. As the colony connects to each individual tree, it ties those trees and other plants together in a complex mycorrhizal network. This allows each tree to share energy with other trees on the network, as well as communicate with each other in what forest ecologist Suzanne Simard calls the wood wide web. Communication is accomplished through chemical signals sent from one tree to another tree through the web, similar to the way birch trees communicate with volatile organic compounds above ground. Each species of fungus will tend to associate with and show preferences for certain species of trees. This particular mushroom is called a birch bolete because its mycorrhizal network primarily associates with birch trees. And this classic-looking deathcap of the Amanita genus prefers the oaks, beeches, and chestnuts here at Lost Creek. Since 90% of all plants on Earth depend on mycorrhizal fungus for their water, nutrients, and the ability to communicate with their environment, it's clear how they play such a vital role in the overall health of our forest ecosystem. Now, let's look at the second category of mushroom-producing fungus in our forests, saprotrophic. It originates from the Greek word sapro, which means rotten, and trophe, which means nourishment. So saprotrophic literally means rotten nourishment.
Saprotrophic fungi derive their sustenance by feeding on dead organic matter. They are the forest decomposers and play an essential role in breaking down that organic matter as part of the nutrient cycle.
Some saprotrophic fungi live on dead animal material or manure, such as this highly toxic conocybe species known as fool's conecap. Others feed on dead plant material, such as tree wood and leaf compost, and it's these types we will be primarily focusing on. Saprotrophic fungi break down dead wood by consuming the cellulose and lignins, which are the components that provide it with structure and support. One type is called white rot fungus, and it primarily focuses on the brownish-colored lignins in the wood, while avoiding the white-colored cellulose, leaving behind a weak, fibrous material. The other type is called brown rot fungus, and it focuses on the whitish-colored cellulose while avoiding the brown-colored lignins, leaving behind a brown, crumbly, chunky material. The decomposed wood is then able to mix with other organic material on the forest floor, with some help from our friendly pileated woodpecker, to create new nutrient-rich soil for use by other plants. Saprotrophic fungi primarily feed on dead and decaying trees, but occasionally a spore will find its way into a crack or wound on a live tree where the mycelium can make its way inside and feed on the dead heartwood of the tree. Here we see hen of the woods, a normally saprotrophic fungus, growing on a live tree. Over a long period of time, it consumes the interior of the tree without damaging the outer living tissue, resulting in those hollow cavities that are so important for wildlife habitat in a forest. Imagine what a forest would look like without our fungal decomposers. With only the insect, invertebrate, and microbe decomposers available, it's unlikely that they would be able to keep up with all the dead organic material in the forest. Animal carcasses, tree trunks, branches, and leaves would build up, not only making it very difficult for seeds to germinate, but making it difficult, if not impossible, for many of the forest animals to move around. Soil production, which already forms at the incredibly slow rate of 100 years per inch, would be even slower, and what does form would be low in nutrients due to them being locked away in all the undecomposed, piled up organic material. We can see here just how thin the topsoil layer is here at Lost Creek, with only 5 to 6 inches of topsoil on top of the sandy clay subsoil. That thin topsoil layer forces many of the trees here at Lost Creek to grow shallow root systems, resulting in frequent blowdowns like this one. So, now we know what a huge role both mycorrhizal and saprotrophic fungi play in our forest. Let's look at the last category of mushroom-producing fungus, parasitic. Parasitic fungi are similar to saprotrophic fungi in that they both obtain their nourishment from trees. However, they are different in that parasitic fungi feed on the tissue of living trees. Spores enter through a branch stub, crack, or wound where they take hold. They then steal sugar energy, water, and nutrients from the host tree without giving anything back in return. This relationship is called parasitic symbiosis. Some bracket fungus, like this horsehoof, can live for many years, and sometimes even decades. The fruiting body does not die off each year like most other mushrooms. It grows a new spore-producing layer each year underneath the previous year's layer. Similar to tree rings, if you count the layers, you can determine its age. This specimen is between 15 and 20 years old. Parasitic mushrooms weaken a tree by robbing its nutrients, and over time, as the mycelium grows in the tree's living tissue, it can disrupt the nutrient flow, further weakening the tree until it eventually dies. This honey mushroom, as with most parasitic mushrooms, also becomes saprotrophic after the host tree dies, and will continue to feed on the dead host until all the nutrients are consumed. Parasitic fungi also break down the cellulose and lignins, just like saprotrophic fungi do, which weakens the tree's structure that can eventually lead to trunk failure. One of the most famous of all parasitic mushrooms is chaga, often referred to as the king of medicinal mushrooms due to its exceptional medicinal properties. Highly sought after and quite rare, it is species selective, only growing on live birch trees. Only 1 out of 1,000 birch trees in a forest will become a host for chaga. We are fortunate to have 5 living chaga colonies in the 150 acres here at Lost Creek. Looking more like a burnt chunk of wood than a fungus, chaga is unique in that the black mass you see is not the fruiting body. It's a type of conch called a sclerotium, and is actually a combination of the tree wood fibers and the mycelium part of the fungus, making it as hard as the tree wood itself. The actual fruiting body is rarely seen because it develops under the bark, and it is only triggered after the host tree dies. Like the horsehoof fungus, chaga is slow-growing and can live for decades, as long as the host tree survives. This specimen is also probably between 15 and 20 years old. There is some debate as to whether or not chaga is a total parasite or exists in a mutual symbiotic relationship with the tree. As it grows, it takes in nutrients from the tree and stores them in its conch, and the mycelium breaks down the cellulose and lignins, weakening the tree. Both are detrimental to the tree and could shorten its life. However, some people hypothesize that if the tree runs low on nutrients due to scarcity in the mycorrhizal network, they can flow back out of the conch into the tree, which would be advantageous to the tree. Chaga could also act like a giant scab, sealing the wound and preventing infection from other fungi or microbes, possibly extending the life of the tree. It is for these reasons that some believe it is a mutual symbiotic relationship. You can decide for yourself. Some even hypothesize that after the tree has satisfied its own nutritional needs, if there are still more nutrients available, it can decide to send those surplus nutrients back down into the network for use by other trees nearby, possibly even directing them to its own struggling saplings, thereby contributing to the overall health of the forest. These are some examples of trees having agency, a concept where trees make decisions, actively playing a role in their environment, and are not just passive bystanders. The outer black layer contains melanin, a powerful antioxidant and anti-inflammatory, in the highest concentrations that can be found in nature. The golden brown inside contains over a dozen vitamins and minerals. Studies have found that chaga also contains several anti-cancer compounds. This makes sense because when the tree is attacked by the chaga, it would trigger an immune response in the tree to produce antibody-like compounds to fight off the attack. The chaga would then sense those antibodies as an attack on it and produce its own antibodies to fight back. Essentially, there would be an antibody war. We can take advantage of all of these wonderful compounds by steeping the chaga into a tea. Surprisingly, it does not taste like a mushroom at all, but has a rich earthy flavor with a hint of vanilla. Be sure to harvest responsibly by never removing more than a fifth from a colony. As fall approaches and the trees begin the process of shedding their leaves, we see yet more examples of trees having agency. Here we have two red maples, identical size, side by side, both experiencing the same temperature, humidity, sunlight, and soil conditions. But the tree on the right has decided to shed its leaves early. Eventually, the tree on the right is completely bare, while the other one still has all its leaves, indicating that trees make choices. Some may decide to hold on to their leaves until the last possible moment to get that last bit of energy, risking snow loading damage. Others are more risk-averse and decide to shed them at the first sign of dropping temperatures. And here we have two white oaks, also the same size, side by side, and in the same ambient conditions. But the leaves on the tree on the left have turned scarlet red, while the leaves of the tree on the right have turned bright orange. With ambient conditions exactly the same for both trees, the only explanation is that one tree has decided to alter the chemical composition in its leaves differently than the other tree, resulting in different color pigments. Fall brings a dazzling array of rainbow colors as nature again shows her artistry. With the seasons coming full circle here at Lost Creek, the cycle begins all over again, and we realize just how wonderful it is to be alive and to be able to enjoy the amazing complexity and beauty